The following presentation was recorded at the 2012 SouthEast LinuxFest in Charlotte, North Carolina. It is licensed under a Creative Commons license. For more information about the SouthEast LinuxFest, visit www.southeastlinuxfest.org. The SouthEast LinuxFest would like to thank the following diamond sponsors in 2012 for helping make these videos possible.
We're going to start the presentation with Sheeri Cabral, and she's the Senior DB Admin and Architect at Mozilla, and her talk is going to be about Intermedia MySQL Administration.
Hello, if you want to, download the slides, they're here. The QR code will download the slides, and also they're on, I have a short bit.ly link. As I was introduced, I work for Mozilla. I have Sheeri.com is where I keep my blogs and my thoughts, at Sheeri if you want to tweet about me. So that's really all of an intro I need. So one thing about Intermediate Administration, I figure you kind of know the basics. How many people here actually use MySQL right now? Most of you. Okay, and how many are just thinking about using it but don't? Okay. Just personal use. Okay, you're still using it. So one of the most important tenets is if you don't plan to fail, you fail to plan, and that's a great cliché, blah, blah, blah. Basically, in this context, what I mean is plan that everything is going to fail. What happens if a machine fails? Because you say, well, let's do the best high availability architecture, whatever, but at some point in time, that one machine is going to fail. So how are you going to plan your architecture around that? Practice failover and switchover. There's a lot of really cool new tools coming out for online alter table and MySQL. But I've been a MySQL DBA for many, many years, and one of the cool things, the benefits of having the offline alter table, when you add a column, you need to take it offline or whatever, is that you come up with these great redundant architectures, and you can do these rolling upgrades, because we had to. So you come up, okay, you do a slave, and then you upgrade the slave, and then you put it back in the mix, and then you take another slave, and then all your slaves are done, and you promote one slave to a master, and you do that. And that's a great fire drill, because if you keep doing that, if you do that once every month or two because you're doing some maintenance, when you have to do it 3 in the morning once a year, you've already done it because you've had your fire drill. So offline maintenance, while it's kind of a bad thing and we're kind of getting away from that, which is actually good that we're getting away from it, don't forget to do your fire drills, and that's really important. So get ridiculous. When you're talking about failover, right, you're like, what happens if the machine fails? And what happens if the switch fails? The switch failing is actually really important. People don't think about in that one rack, what about that switch failing? Because they put their 2 machines in the same rack and the switch fails and they don't know what to do. What happens if DNS fails? What happens if the whole data center fails? Okay, you have the 2 data centers fail. What happens if aliens come out like they do in Independence Day and they shoot down New York and LA, and that happens to be where your data centers are? And the title of the slide is Get Ridiculous, because the point is, it's like load testing, right? Somewhere in load test, you don't load test to be like, well, can we handle 10,000 users? No, you load test, you're like, when does this fall over? I want to make it fall over. Is it 10,000? Is it 100,000? You don't just stop at 10,000, you look to see when it falls over. The same thing with high availability. At some point, your bosses can look at you and be like, that's just ridiculous. We just have to take that risk. If you're Amazon.com and you lose all the orders for a whole day, you're going to think, we can't do that. Lose all the orders for a whole day? That's a lot of people mad at us. But you know what? If that day was September 11th, 2001, people are going to forgive you. One of the weird things about being in the cloud is whenever Amazon's cloud has an outage, everybody kind of understands, oh, your website was down? No wonder, it was the Amazon cloud outage. Okay, lots of websites were down. But if you're just down and there's nothing else related, people are like, why is your website down? So it's kind of funny that you could even go, I would actually venture to say, you actually would get more forgiveness going to a less reliable service. Let's say you had metrics that said Amazon was less reliable than something you could build. You actually get more forgiveness from users because they understand. It's a context and it's an event that they understand more. So anyway, what happens if the entire backend network fails? Again, at some point your boss can be like, that's ridiculous. Well, that's the risk you're going to take. And you have to take those risks knowingly. So let's talk a little about hardware. What should I buy to put my MySQL on? Well, basically, I would say 64-bit hardware. One thing about MySQL is that it is a single-threaded process, and that's the MySQL daemon, the server itself. Now what that means is that if you're on a 32-bit architecture, you can use about 2.4 gigs of RAM before MySQL can't use any more RAM. So you could have a 32-bit system with 64 gigabytes of RAM, and MySQL is only going to use about 2.4 of it. So use 64-bit RAM. You'll use the 64-bit architecture, and hopefully a 64-bit MySQL package, and you'll actually get the most out of your machine. You want to use as much RAM as you can, as much memory, because MySQL heavily uses memory. If it can't use the memory, it has to go to disk, and disk is slower than memory for the most part. So I advise getting as much RAM as possible. How much RAM do you want? Well, what's your working data set? Your entire database might be 500 gigabytes, but how much is being used at one point in time? Is it 100 megs? Is it 50 gigs? You know, you want to get as much RAM as possible. If you have a 10K database, you don't need a lot of RAM. Or, you know, even, you know, a lot of people have something like a 40 gigabyte database. That's great, but your working data set is probably about maybe 10 gigs. Right? How much is really active and coming in and out of the buffers at all times? And I/O, disk I/O. This is usually the bottleneck is some kind of either network latency or disk I/O with MySQL. So you want to think about what's going to get you the fastest I/O and how you're really going to manage that effectively. So I have a little thing about RAID here. Has everyone seen this, by the way? This is kind of awesome. It's all rights reserved, so I'm probably not actually allowed to show it, and its URL is down there. But RAID is explained by a water cooler. So the one all the way on the left is standalone. That's no RAID at all. The second one is cluster. The third one is hot swap. So you can see like the water, and they actually just changed the water bottle here, so that was kind of funny. But anyway, so RAID 0 over here is actually pretty cool. It's two bottles on top of each other, so you can see that that is striped, not mirrored. You guys are all Linux people, so I'm assuming that most of you system administrators? Yeah? So I probably don't have to explain this too much, but for me, I'm like, I don't know what these things are. RAID 0, RAID 10, what's that? So that's striped. You can see the RAID 1 is mirrored. RAID 5, you take three or more disks and you combine them together. And then RAID 0 plus 1 is you get 50% of your capacity, but you get the striping and the mirroring. And it's just a really good diagram. And so MySQL, the company, used to recommend RAID 5. I think they still do. I think you can get away with RAID 1 if you really wanted to. Disks are cheap. Servers are cheap. With things like the cloud, you can spin up another server. Disks are pretty reliable these days, unless you're using, you know, a non-journal file system. Like if you want to use ext4, I've seen a lot of corruption on that. Like you use it for like a day and it gets corrupted. But if you're using ext3 or some kind of journal file system, they're pretty reliable. They're not going to fail that often. And so I would say, you know, use whatever you want. But remember, like if you're thinking, okay, this is going to die, let's say, once a year. Your disk is going to have a data corruption once a year. Well, is it a big deal once a year to add another slave and take that disk out and reformat it? Not really. And when you make that new slave and you reformat the old hard drive and make a new slave, you get to test your backups because you're restoring it. So it's a good exercise. A RAID note. You want to, if you are going to use a RAID controller, you want to get a RAID controller that has a battery-backed write cache for both performance and safety. So if the power gets shut down, it's going to have that battery-backed write cache to still finish writing that transaction. And in fact, MySQL is not going to be fully transactional unless you have your disk has battery-backed write cache. Another note about RAID, do I have that on the next slide? I don't. Another note about RAID is that your RAID controller is still your single point of failure. So as far as I know, correct me if I'm wrong, raise your hand and tell me, as far as I know, RAID controller is still a single point of failure. Is there a way to get redundant RAID controllers? No? Yeah?
Two RAID controllers and have them get the term is for it, but they will both do the same operation at the same time.
So the common is you can get basically mirrored RAID controllers. But is that easy to do, or is that like you have something sticking out of the hardware kind of thing? Or?
You just got to throw money at it. They're kind of expensive.
Okay, you got to throw money at it. It's kind of expensive. Okay. So yeah, it's not a standard feature, but it can be done. So that's good. So yeah, if you're getting RAID, get the expensive, not single point of failure. Get your mirrored caches. What about SSDs? They're definitely a valid choice. People are like, well, are they reliable with all the writes and everything? Because I heard that you can't write to it too many times. These days, SSDs are pretty reliable, assuming, of course, you have power loss data protection, so that it will, again, it's kind of like your battery-backed write cache on your disk. But one of the things is, you know, I don't know about you guys, apparently I'm kind of old school. I didn't think I was that old school, but apparently I am. Since I've given HIPS talk, I was one of the only few people who knew how to use ED. we kind of grew up on, you know, you want sequential writes. Sequential writes are really good because the disk head is spinning, and so you don't want it to spin too, you don't want to have to travel too far. You don't want the head of the platter, I guess what it is, spinning too far. So if you have like a sequential log file, you want to put that on like a separate disk than your data, because, you know, this will just write here, and your data, your head is going back and forth and back and forth. That's not going to be something you have to worry about with solid state disks, because they are you know, memory-based, hash-based, so it takes just as long. You know, it's still O of n to retrieve one record and one record. It doesn't matter if they're sequential, because they're not actually sequential on disk. So just think about what you're doing, and I would say benchmark your application, because MySQL uses B trees for internal structures for the most part, for default tables. Both MyISAM and InnoDB use it as default for their tables and for their indexes. So B trees work really well with range queries, and all that kind of stuff works really, really well with spinning disks. So just check your assumptions and kind of think about like lower level all the way down, what's happening, and really, or don't think about it and just benchmark and say, does it work better for my application? It either does or doesn't. Sorry, my husband is texting me. So I just, well, it will keep going if I don't actually look at it. So anyway. Partitions, so file partitioning, temp and RAM disk. If by default MySQL uses /temp as its temporary file holder, you should change that, or if it's a RAM disk or not, you can change the parameter. I'll show you how to change the parameter later, because what happens is it can be removed at any time. So you don't want to have the problem where replication's going and it's loading in a big file and it's using the temporary files, and then it just dies because the file was removed by the file system. And what happens if your partition fills? Look at all your partitions. If this partition fills, what happens? If your logs partition, if you do separate your data in your logs, or wherever your data are and your logs are, if those partitions fill, or if it's one partition, MySQL just sits there and hangs. It's just going to hang and says, oh, I can't write that log? Oh, okay. I'll wait till I can. Still can't write that log? Okay. But MySQL is still kind of like active, and you may be able to still make like a connection to MySQL, but you'll never leave your connection because you'll try to do something and you'll just sit there and hang. So be very careful. Make sure you're monitoring your disk and all that kind of stuff. Where do you put your data versus your logs versus your backups? Your logs are actually your incremental backups. So if you have some kind of policy where your data is in one place and your backups are in another, for just safety, if they're on different disks or something. So if one disk dies, you still have your backups. I know we're talking about local disks, so backups don't necessarily go there, but some people have these kind of policies in place. Think about where they're going. And just note that if you are backing up by doing an LVM snapshot, it doesn't work across more than one partition. So if you had, say, your logs and your data, and they were on different partitions, and you wanted to snapshot them together, there's going to be a split-second actual difference. I don't know if is that how most snapshotting works with ZFS also and Amazon EC2? Does anyone know? I don't know if it's a property of snapshotting in general or LVM in specific.
It's more of an LVM specific limitation. ZFS can do a whole lot more, but a lot of that's going to have to do with how you organize your ZFS file systems to begin with.
So the answer is maybe.
Yeah, you can set it up to do atomic snapshots with ZFS across multiple, but that's all going to be how you set it up to begin.
So it does seem like that specifically is an LVM limitation. It's not necessarily a ZFS limitation, but it could be depending on how you set up ZFS. Okay, so let's talk about some Linux operating system tuning. I'm only going to talk about Linux since it's LinuxFest. Swappiness. So swappiness is like gas in your car. When do you fill up gas in your car? Do you fill up gas in your car when it gets to a quarter tank? When it gets to like an eighth of a tank? When the light goes on? Like 5 minutes after you've run out of gas, you call AAA. That's what swappiness is. Swappiness is when should I swap my files? Should I swap it when I'm like starting to get low on available memory, or should I like do it like when I've run out of available memory? So a swappiness of 0 is like when you have no more memory, then swap. Swapping is a lot of overhead. Hopefully you're not running anything else on your MySQL server, like you're not running Java or something on your MySQL server. You're separating those services out. So assuming that's the case, you want to set swappiness as low as possible, because you only want swapping to happen if it's actually needed. So yeah, as for open files, you want to make sure you have open files limit is unlimited as the root user. The reason, and that's usually by default, the reason for this is that you don't run MySQL daemon as root, but you run the wrapper daemon called MySQL dsafe as root. And what that does is it checks, like every so often, makes sure MySQL is running. If MySQL daemon's not running, it starts it again. So what it does is it forks off and it actually runs the MySQL daemon as the MySQL user. But because it forked it off, the MySQL process inherits the ulimit from the parent. So that's how you kind of get the unlimited ulimit, but also have the security of not running as root. In the Linux 2.6 kernel, you have an I/O scheduler choice. It's not just the elevator scheduler, I think that's what it was called before, in like 2.4 and below. There are a bunch of different I/O schedulers. There isn't like one recommendation like, oh, this one will always be the best. But if you want to play with that kind of level of I/O, working with I/O, then just test it, because there's, different workloads will have a different best I/O scheduler under Linux. Just other daemons, that's just a note to be like, are you running something else? Are you running like your web server on your MySQL server? If you are, then some of these tuning variables might be a little different. And usually that's not recommended. There are some cases in which you would do it. For example, for security reasons, if you wanted your database on the same machine as the web server because you didn't want your database to be exposed, you didn't want it to even listen on TCP at all, for example. You might do that. So it's a valid reason for doing that. Yep?
In particular, anybody who's doing a server in a bottle where they're running Apache and MySQL and everything on one box, don't set swappiness too low, because you'll have a lot of overcommits with PHP, and if you've got your swappiness set above 0, your overcommits, nothing actually gets written to swap, but it can commit, the kernel will commit to swap. Instead of pushing I/O cache out of RAM, if your swappiness is set to 0, nope,
right.
There's your I/O cache.
So the comment was, if you have several daemons running on the machine, you don't want to set swappiness so low, because that will give you a lot more overhead. MySQL replication. MySQL replication is a two-threaded process. What happens is you have the master. It's a pull from slave. So when you have a master, it's not like I'm the master and I'm going to tell you, the slave, what to do. No, the master logs its change log to the binary log. So any inserts, updates, deletes, any transactions that might contain any of that kind of stuff are logged to the binary log. Binary meaning having a change. There's a lot of different meanings of the word binary in MySQL. Anyway, so it's a binary log, it's a change log. So the master logs the binary log, which are also your incremental backups, because they're your change log. And as slave comes around, how do you say something is master slave? You go on another MySQL server and you say, you go look at this person, this server over here, and get their binary logs, and you're gonna, so it's pull from slave. You configure it on the slave. The master doesn't, it doesn't have to be aware at all. There are ways you can make the master aware, but there's really no awareness of the master. So it's a pull from slave, and there's two threads on the slave. One thread connects from the slave to the master on port 3306, so using a MySQL user and all that kind of stuff on port 3306, and says, or on TCP anyway, because you can change the port, and says, give me your binary logs, and that's called the I/O thread. So what that does is it reads the binary logs from the master and saves it to a log on the slave called the relay log, because it's relaying the binary log changes from the master to the slave. Then an SQL thread comes along on the slave and says, reads that relay log and says, okay, now I'm going to apply those statements. So that's really important, because a lot of the ways in which MySQL replication works and does not work depends on you understanding how that is. This is why MySQL can't really have two masters, because how would you interleave the binary log? That would be kind of weird, and how would you know which came from where? Let's see, ignore. So in MySQL, there's a bunch of ways that you can say, this stuff on the master, I don't want it to appear on the slave. That's usually not the greatest idea in the world to do that, but there are use cases for it, so I'm going to talk about it. When you're ignoring stuff, you can ignore it in the binary log. You can say, master, don't even log this in your change log, which is usually a pretty bad idea, because then you don't have that in your incremental backups, right? All record of that change happening, it never gets recorded. So you've just lost some auditing capabilities, and that can be a pretty bad thing. Now, I have had a case where the master was logging so much information that even then we didn't need it on the slave, that even though the slave had the table set to be a black hole table, which is pretty cool. It's like all the information goes to dev null. what happened was the bandwidth, there's so much bandwidth was being used that the slave was always behind. It was just the bandwidth. It wasn't even the queries themselves. But there's also a way to ignore things from the replication side of it. So the slave would go read the binary log on the master and then not save that to the relay log. So that would be the preferred way of doing it, although the preferred way of doing it is not doing it at all. Monitoring. I happen to use Nagios. There's a plugin I wrote for Nagios that I think is pretty good. There's some Percona tools for monitoring in Nagios, and there's that's for alerting. There's some Cacti templates. I think there's some Zabbix templates as well. I know there are actually. So monitoring kind of encompasses two things, alerts and graphing. Only alert on what you can fix. If you alert on the fact that there's a lot of slow queries, how are you going to fix that? Why should you get paged at midnight that there's a lot of slow queries? What are you going to do about it? You're going to kill the slow queries? You can make something that will kill, you know, long-running slow queries. Are you going to monitor when things start to get up towards max connections? That's a great idea. You can fix that. When things start to get about 80% of max connections, you can log in and be like, what's using all these connections? I want to make sure I'm not going to go up to my maximum number of connections before, because then MySQL won't accept anymore and you'll not be able to use MySQL. Graph the important stuff, and when I say the important stuff, I mean anything you might, I tend to just graph everything I can. I take the Cacti templates or the Zabbix templates and just say, yes, graph all of them. Because you kind of never know what you might need. I mean, if you're not using the MySQL query cache, then don't bother graphing it. I tend to like to graph it anyway because sometimes some setting gets reset and you never know, and we start saying, hey, how come there's a query cache being used? That shouldn't be on at all. So I think it's pretty useful, even though sometimes you'll get blank graphs. That's as it should be. And you want to make sure that's as it should be. When you monitor things, whether it's graphing or alerting, you want to get as close to the user experience as possible. Do you really care that your web server is, or your database server, for example, is sending back the fact that, yes, you can connect? Or do you want it to like run a query and make sure that something in a queue is, you know, there's a queue being processed? You know, that's really important. Again, it's like, you know, your web server. Do you really want to know that you're getting a 500 OK? Or would you like to know that you're actually like rendering a real web page? Preferably the latter, because you can actually have problems and get a false positive even though you're submitting a 500 OK. So try to monitor as close to the user experience as possible. I could go on and on about monitoring, but this is an hour-long talk, and I could do an hour-long talk just on monitoring. So there you go. Backups. Have them. Who here has backups? Who here doesn't have backups? Don't be shy. Okay. Who here, what do you guys use for backups? Just call it out.
MySQL dump.
MySQL dump. Anybody's, anything else? RBS snapshot? RDS. Oh, Amazon RDS snapshots. Anything else?
LV snapshots and rsync.
LV snapshots and rsync. Okay, so we've got some file backups, some physical backups, you know, with the snapshotting, and then you've got logical backups with MySQL dump. What a logical backup is it gives you a series of statements that's like, you know, insert into this thing. So when you're restoring it, it usually takes longer to import the MySQL dump. One of the things I like to do is mix and match. So I'll do a MySQL dump, and I'll use the -- skip extended insert parameter, and what that does is it gives you one row per line. And so if you're doing something like, oh my God, we dropped this user because he didn't pay, but he's like, you know, the brother of the owner, and we got to restore his account, instead of having to take, let's say, a physical backup, restore all the files, or a regular MySQL dump, restore everything, and then, you know, select his entries, what you can do is you can just grep for that user ID in the thing, because it's one per line, and just restore that. So so the question is, what's your disaster? Is your disaster someone dropped a table? If it is, do you really want to have to like restore the whole backup just to get that one table? Or is the disaster like the whole machine died? Usually when we think of disaster, we think of the worst disaster, but you also need to think of, you know, kind of what might happen too. Some people do things like have a delayed slave. That can be useful. Maybe in a development environment, if you really think you need a delayed slave. So delayed slave is a slave that is not exactly current with the master, but you might say, well, I want a slave that's 4 hours delayed. And what will happen is the IO thread will save the logs, but the SQL thread won't apply the logs until the time in the log. So the time is recorded from the master. So the time in the log says 4 hours ago, it'll say, okay, now I'll apply the logs. The other caveat of that is make sure your servers have the same time, maybe NTP server, check them, make sure that works, because that can be fun too. At any rate, some people say, well, you know, we'll do that. That way if someone does a drop table, you know what, if someone does a drop table, I want them to have pain to have to restore it, because they shouldn't be doing that. But some people have different needs. My thing is, what happens if somebody does a drop table on a Friday, you don't notice until Monday? Like, how long should your delayed slave be? That's my problem with delayed slave. The concept is great, but like, what's the limit? And if you're past that limit, then why bother having a delayed slave? So anyway, test your restores maybe once a quarter. Again, I like this whole, you know, having the offline maintenance thing, because I can go and, you know, make a backup server. I can go and restore something. I'm doing a fire drill. I'm testing the restore to make sure that I know before the critical time period. If I'm building a new slave and I'm like, wait, this backup doesn't work, I have a couple of days. Like, it's not like, okay, we need a slave now because something died. You don't want to find out then that your backups haven't been good for 6 months. Pro tips. If you're using the MySQL command line, \G, who knows about that? Awesome, okay. \G gives you the output in vertical output. By default, when you do a command on the MySQL command line, you get a horizontal output. So if you do like select star from table, and there's a lot, you know, it's longer than your thing, it wraps around, it's very hard to read. \G gives you a vertical output, which does one, actually, let me show, I can probably show you something like this. Am I still connected to the interwebs? Yes. Use bugs. This is our Bugzilla instance and that I'm connected to. So if we do select star from bugs, limit 1, see how annoying that is because that table is so very long?
The bane of my existence.
Right. Okay, I take the semicolon away and I put a \G. And look at that. Exactly. You can leave now, you've learned enough. No, it's actually really cool. Another cool thing is when you have a big table like that, \P is your pager. That means like, how do you want to page? You can do more, you can do less, you can do, so more gives you select star from bugs limit 1. Oh, I hit the space bar, I can get more. Yeah, very, very nice. I can hit Q and I'm done. And it still gives you 1 row in set, so it still gives you the number of rows in set. So if you have a lot of things in your process list, you might do a show process list like that. Oh, there's only 3. This is a slave that's out of the loop. But if there was a whole lot, you could hit Q. It'd be like 8,700 things in the list, which is really very nice. The other thing you do is like \B, grep, if I could actually type, grep for seconds. Okay, so now the pager is set to grep seconds, and I can do a show slave status, which by the way I always use \G for, and you get seconds behind master without all the stuff. So I'll do something like this. Another one actually that's not even on this is the do command. And what the do command does is it does the same thing a select command would do, but it doesn't give you the results. Why would you want that? Well, there's this really cool function called sleep. You select sleep 1, it sleeps for 1 second, and then gives you stuff back. Oh, I was still on the grep pager. So, but it gives you this output. So if you use the do command, I end up doing something like this a lot, where I want to like kind of follow the show slave status. So I'll look and I'll look and I'll look, except I would have the \P grep for seconds, and then do that again. And then you get this little nice little kind of thing, so you don't have to remember what it was, the whole screen didn't go by. It's a lot more effective when the slave is lagging behind and catching up, but you get the idea. The other cool thing is if you make a lot of typos like I do, like you do like delete from foo, and you're like, oh wait, I wanted to type select from foo, but you're way too lazy to do like Control-A to go to the beginning of the line or something like that. If you just want to cancel it, you do \c, and that just cancels the statement. It doesn't run it. So then you can kind of go up, you can hit the up button and go left and be like, oh no, I wanted to do select from foo. Things like that. So those are my pro tips. The other thing I figured I should mention is, I think we're all pretty comfortable with the command line, but if you did want like a centralized GUI tool, MySQL Workbench is free and can do a lot of stuff. There is a paid version. I haven't felt the need to use the paid version. It does a lot of cool stuff. It does also diagramming and modeling. So if you want an entity relationship diagram in MySQL, or you just want pretty pictures to be like this table refers to that table, you can do that in Workbench. And it does things like you can reverse engineer a schema into an entity relationship diagram. You can also do something like take 2 schemas and compare them and be like, oh, how would I alter my production schema to look like my development schema? I use that a lot. So that's actually a lot easier than diff, because diff will show you some other things, like if your indexes have different names or something. Diff doesn't catch that, but Workbench does. So how about some built-in tools in MySQL? What can we use that can help us administer MySQL, make it run more smoothly? Stored procedures and functions. MySQL does have stored procedures and functions. Oh, sorry about that. Gravity really works today, by the way, just letting you know. MySQL does have stored procedures and functions, and they can be used to be, you might have heard that, oh, but the implementation's not so great of the functions. It's not, but what it does have is it has regular SQL, but it also has some conditionals and loops and things like that. So what it does let you do, and eventually it'll search and I'll find it again, there are conditionals and cursors in MySQL, stored procedures and functions. So I know I've talked to a bunch of people and they're like, yeah, but stored procedures aren't good in MySQL. I'm like, well, what more do you need other than loops and conditionals and cursors? And they're like, oh no, that's pretty much all I need. I just need to like go through a list of, you know, rows in a table and, you know, do something, do some variable, you know, do some calculations if something matches something. That's pretty much what a lot of stored procedures are. What they allow you to do is they allow you to have a certain functionality, and all you have, the only power you have to give the user is an execute of that stored procedure. So you can put some business logic into the database if you really want to. You know, there's different camps of whether or not you should do that. Views are also good for security. They're, you can think of them as virtual tables, and by virtual I mean they're not materialized at all, they're not physical, they're just a view into it. The way that you define a view is you do like create view foo as select whatever. So it's some kind of select query. You can do joins, you can do whatever. You just have to be careful, because if you're making like a really complex view, or you're using a view on a couple of tables, to your developers that view might look like a table, and so they might do some kind of query that looks right and looks like it should be really simple, but then it ends up not using any indexes or whatever when you're actually you know, looking at it. Events. Does anyone here know about MySQL events? Who here runs any cron script with MySQL? Like some cron script that connects to MySQL and does some functionality, like maybe caches some stuff into a table every 5 minutes or something like that? Nobody? Well, if you did, MySQL events would be for you. Because what MySQL events does is it runs SQL code, stored SQL code, and it can even run stored procedures and functions inside a cron or at-like kind of environment, but it's inside MySQL. So one of the cool things about it is that it does it because it's inside MySQL, and you can say, okay, you should run this as the X user. You don't have to actually store a password anywhere because it's already in MySQL. So if you had like a cron job that would connect to MySQL every 5 minutes and update a table with, let's say, a count star of who's logged in, you would have to put the password somewhere on the file system. With events, you don't have to do that. And then another tool MySQL gives you is partitioning, and I specifically said for defragmentation, because one of the cool things about MySQL partitioning is that underneath it's just an extra file. So by default, MySQL will have like a structure file, and then assuming you use certain commands and whatnot, InnoDB file per table, for example, you have one file with the data for that table. If you use partitioning, you'll actually have one file per partition. Now in MySQL, if you delete rows, you're just deleting them. You're not actually defragmenting the table. So if you have 1,000 rows in a table and they're all the same size, and you delete 100 of them, the file is going to be just as big, but it's going to be 10% fragmented. And so you would have to rebuild the table, either doing some kind of alter table or by doing an optimized table to reclaim that disk space. With partitioning, what you do is you can drop the partition, and in the time it takes to basically delete the file on the underlying file system, that data is gone and there's no fragmentation that's happening, at least not within MySQL. So that's something that's really, really useful. A lot of people have kind of windows onto data, and they're like, oh, we only need to see the last month's data, and they don't understand why after like 6 months their application is so slow. And it's like, well, you deleted the data from 2 months ago, but you never really defragmented the table, and by the time you've deleted 6 months worth of data, you still only have 1 month in the table, but it's now 7 times the size. There's a Percona toolkit. It's actually pretty good. There's a lot of tools for things like data integrity with PT table checksum, PT table sync. This is a way to check if your master and slave have the same data, which they don't always. They don't have to, because again, Replication is just the slave going to the master, taking the commands and applying them. And you can have either doing the SQL commands themselves, or you can have row-based replication, which just takes the changed rows and applies that. However, there's no checks and balances to say, like, hey, you know, did this happen correctly? For example, especially in statement-based replication, if you do an update and you say update table set foo equal to bar, where, you know, this field is less than 1, if those tables are different on the master and slave, maybe there's 10 rows that match on the master and 9 rows that match on the slave, now your data gets even more out of sync. So there's ways to actually check that with the Percono toolkit. They have tools for, there's a couple dozen tools. There's really a lot there. And there's ease of finding information. There's a tool called PT Show Grants, and that will show you the grant statements for everyone on the machine, or you can specify only certain users, which is really useful when you want to find, like, oh, well, show me everyone who's in the 10.2 subnet, or, you know, show me everyone who has the super privilege. You can do that with a query, but you could also do that with PT Show Grants. If you wanted to, for example, actually a better example would be, I want to copy all the grants on this machine to another machine. You probably could, like, export the MySQL system database, but it would be a lot easier to run PT Show Grants. You get the text file, then you run that file on the other machine. There's a query digest and review tool, and so it can take any kind of log, whether it's log from TCP dump or a log from the general log or the slow query log, and you can actually get like a fingerprint of the query. So you can actually say, what are the queries my system does? Like what types of queries? You know, it kind of, it digests it up so that different values aren't represented, but just says, okay, there's a number here, right? But one of the queries that you do is select name from user where user ID equals X. That's a fingerprinted query. And so it's actually pretty cool to be able to go through and review all your queries. So I do this thing I call a query review. So when you first do it, there's a lot of queries to review, but then you can kind of see like, oh, there's a new query that came in, right? In last week's release, I see there's a new query. And there's other tools. Some of them work, some of them don't. I feel like every time I use a new Percono tool, I file a couple of bugs. But there's kind of no alternative in a lot of cases. So, you know, it's a love-hate relationship kind of thing, and there's not, some of the documentation's really good, some of the documentation's less good, and sometimes it's hard to find examples of how to use stuff. So, you know, but it does a lot of really cool stuff that you wouldn't otherwise be able to do. So, there's also the OpenArc toolkit, which is by another like community member. It's not as like widely popularized because it's written by one guy, as opposed to like a company that has a lot of buying power. But there is an online schema change. You can block accounts. You can kill slow queries. You can repeat a query execution. These are some of the things that you can't do in other tools, although you can do online schema change in the Percono toolkit. It seems like it's kind of, it's not production quality yet. Like Baron just posted the other day and he's like, well, if you're using it, let me know if it corrupted your data or not. And I'm like, He's like, well, I tested it on my stuff. And I'm like, like, I know you're coming from a place where you're like, it didn't do it on mine, so let me know if it did it on yours, but it's still kind of like, keeps me up at night. So yeah, there's also things like tool to do security audit on accounts and privileges and a lot more stuff. So that's actually also, I mean, these are all open source stuff. Like, I think they're all written in Perl. There's also Security, which is by Darren Kasser. Actually, OpenArc is by Shlomi Noach, who's over in Israel. Security is by Darren Kasser, who is, I think, in Silicon Valley. But it's another community-written, open source kind of toolkit. And basically, it's for ease of user administration. It's a bunch of store procedures and a table or two to store things. And you can do things like clone users, block users, and use roles. So those three toolkits are actually pretty good, good Swiss Army knives for what you need to do with MySQL. Speaking of users, here's something interesting about MySQL. Users' names are not unique. If you have the username Sheeri or the username Nagios, that's not unique. What's unique is the username at the host. So Sheeri at 127.0.0.1 or Nagios at monitoring.mozilla.com. Those are unique. What does that mean? Well, that means you could have two users with the same username, different hosts, and, different privileges, different passwords. That's always a lot of fun when you find that. For example, I just found something, we were moving data centers, and we had two data centers, like this one and this one, and we were moving from here to here. And so I was moving databases, and everything that had a subnet here I changed the subnet there, but what happened was they had changed the password here. So I've been using an old password. I'm like, okay, your new server is ready. And they're like, no, it doesn't work. And I realized I went on this server. I'm like, oh, it's a different password. Okay. So be careful of that. And if you do change a password, make sure there's no other user on that system, or you change that other user, same username, different host, to that password as well. A note about the super privilege. The super privilege is what makes something, kind of the root user. The user root is not special in MySQL. Anybody with the super privilege has the same powers as root. It's not like, the Linux kernel, where you have UIDs and anything under a certain amount. No, not like that at all. If you have the super priv, that's enough. So what does the super priv do? Why is it such a powerful thing? Why should you not have people who have the super priv? Why should they not, why should that not be given out liberally? Why shouldn't everyone just have the super priv? Well, the least of your worries is that they can shut down MySQL. And they can do a MySQL admin shutdown and shut it down. That's the least of your worries. One thing that you can set on a slave server is you can set a variable called read-only. By default, that's off. So by default, it's not read-only. That's good. But on a slave server, you might want to say, I don't want anything to write to this server. Well, somebody has to write to it, right? Because replication has to write to it. So replication is the system user, and anyone who has the super priv can also write to that database. The awesome part is, and I say that sarcastically, is that MySQL doesn't even give you a warning. So if you just log on and you're always logging on as root and you write to the database and you didn't realize you were on the wrong system, you don't even get a warning. It doesn't even say hey, by the way, this is a read-only system and you're about to write to it. Nope, just writes to it, no problem. So that's the second reason not to use the super priv. The third reason not to use the super priv is I referenced a variable called max connections earlier. By default, max connections is 151. Why 151? Well, it's one more than the amount of max clients that you get with Apache. Anyway, let's say you set it to, say, 2,000. What happens when you hit 2,000? MySQL says, oh, no more TCP connections allowed to me. Sorry, go home. Well, that's not exactly true. MySQL does give you one extra connection to somebody with a super priv. So if your max connections is set to 2,000, you can actually have 2,001 people connected. That way you can actually log in and debug what's going on, because if you have just something that's slamming MySQL with queries, if you restart MySQL, you'll just be slammed with queries again. So that's one reason not to, so you don't want to necessarily give your, say, application user super priv, or your monitoring user a super priv. Sometimes you need to give your monitoring user super priv, but. All right, what about locking? Table versus row. So MySQL has specification to do table level locking in the server itself. Any other kind of locking, whether it's page level locking, which used to be in BDB, but BDB doesn't exist anymore, or row level locking, which is in InnoDB, ExtraDB, or whatever you use, that's in the storage engine itself. So any storage engine in MySQL will be able to do table level locking. Anything more granular has to be defined in the storage engine itself. MyISAM does table level locking. This means if you want to write to MySQL, you have to lock the entire table and nobody else can read from it. So that is a really, really, really mutually exclusive lock. With InnoDB, you'll lock the row that you're writing to and nothing else. And if you're inserting, you might kind of lock that in the next row, but pretty much it's row level. Does anyone here not know what a deadlock is? Okay, a deadlock is, let's say you have two transactions going on. So this transaction says, I want to write to these two rows, so it locks those two rows. But it's not done with the transaction. So this one says, I want to lock this row here. So this one's locking these two rows, this one's locking this row. Now this one needs to finish the transaction, so it wants to lock this row. And this transaction wants to lock these rows. Well, neither transaction is going to give up the locks they already have, because they're not done yet. But so it's just it's a stalemate, right? It's a deadlock. That's what it is. It's a stalemate. So MySQL actually can recognize when this happens, and there's a certain timeout after which it will say, okay, I'm rolling back one of these transactions because it's a deadlock scenario. Buffering. We love memory. Memory is great. Caches are great. Buffers are great. File system buffer. So MyISAM by default doesn't. It has an index buffer, but not a data buffer. By default, InnoDB has, and when I say by default, you can't really change that. InnoDB has one buffer for data and indexes. So MyISAM does not use a data index. It relies on the file system to use data indexes for the data files. So that could be, if you're using MyISAM, which I don't recommend for transactions, just saying, it is good for data warehousing. But most people are not using data warehousing. Most people are using it for like their, their websites or web applications. So the file system buffer, you might want to use direct.io for for being able to bypass the file system buffer. That would be for InnoDB, because InnoDB has its own index and data buffer. So why would you need extra buffering from the file system as well? That would rely the daemon to provide the buffering. So you might want to think about how your I/O is happening. If you're using InnoDB, you might want to do that. And again, test it, because I can tell you 6 ways till Sunday that direct.io will be faster on InnoDB, and you could have the one application in the world where that's not true. So it doesn't really matter if 99% of the applications out there follow a rule if yours is the 1% that doesn't. So that's just a note in general. So now I'm going to talk about some configuration options. The top says a note on underscore versus dash. You might see something like a variable with more than one word separated by dashes or separated by underscores. Here's the deal. In the MySQL configuration file, a my.cnf file that you might have seen around, you can use either the hyphens or the underscores. If you're setting variables on the MySQL command line, it thinks the dashes are subtraction unless you like escape things. So you can escape the whole word. But I don't like escaping things. The quotes are like where my pinkies are. I never use my pinkies, right? So I always use underscores because it's just easier that way, so that I'm never like copying and pasting something and accidentally doing subtraction and whatever. MySQL tries to be really helpful, so it might be like, oh, you want something to be 0. Okay. You're subtracting something and the word is 0. I don't know. MySQL also tries to be helpful. I found this out the hard way. So there's a parameter that you can use in certain directives under the my.cnf. And if you've used the my.cnf, you've seen directives. A directive is just the little thing in brackets that says MySQL or MySQLD or client or MySQL dump. Well, MySQLD safe can use the group option, which sets the groups of the files, but not the MySQLD itself. I think I misspoke there. MySQLD safe will use it, which is the wrapper, but not MySQLD. However, MySQLD thinks when you say group, well, you mean group concat maxlen, which is the maximum length for a group concat, which is a certain function in MySQL. So we'll say, oh, it basically will try to expand it if it's a unique kind of prefix. And so it tries to set it to MySQL, but that's not a valid number. But it's when I convert that to a number, it's 0. So what it'll try to do is you'll get these like warnings of like setting group concat max len to, I don't know, I'm truncating it, it's 0, but I can't set it to 0 because the lowest number I can set it to is 4, because that's the range. So you see these like weird errors and stuff. And it's because MySQL will actually expand something. So if you actually type like a variable, it would expand to a variable with more than one word, assuming there's only one variable that starts like that. So if you start to see weird errors in your error log, check your variables, that might be why. So some configuration variables you might want to look at and or change. This is kind of like this is what I learned this weekend itself, and I'm going to look right now and see what happened. Your data directory, where are you storing your data directory? Are you going to run out of file system space somewhere? Varlib MySQL is the default space that things are stored in. Some people like to have additional space on like a NetApp or something that they'll use. Tempter, I already said don't point it to a temporary directory or to a battery back write cache. Some people like to put their temporary directory in their data directory. That could work. You might also fill up your data directory partition if you do that. So it's something to think about. Default storage engine equals InnoDB. Again, if that is what's good for you. Most people, though, I'd say 95% of the time, what you want is InnoDB. By default, MySQL is MyISOM until MySQL 5.5. Now, I would recommend that everyone get on MySQL 5.5. It's been generally available since December of 2000 and, what are we in, 12 now? So it was December 2010. So it's been a year and a half that it's been GA. It's solid, it's stable. I'm moving my stuff over from Mozilla. I'm moving stuff over there. I only started working at Mozilla about 6 months ago. So we have some things on 5.0 and some things on 5.1. Most of the stuff's on 5.0. And we're changing to 5.5. So I would definitely recommend that. And not only am I recommending it, I'm practicing what I preach. Concurrent insert equals 2. I did kind of lie to you before when I said if you wanted to write to MySQL, you had to lock the whole table. If you want to insert, because MyISOM will actually insert concurrently, so it inserts, not concurrently, it inserts sequentially, so it inserts the next row and the next row and the next row. What you can set is you can set concurrent insert equals 1, and what that will do is it will allow more than one insert to happen at a time if you are just inserting to the end of the table, and if there's no fragmentation in the file itself. Concurrent insert equals to 2, and what that means is it'll actually try to go back and like fill in the fragmentation if it's there. That's why you can't do it concurrently if it's like that. If your concurrent insert equals to 2, it doesn't care if it's fragmented. It will actually just, you know, append things to the end, but your fragmentation does get a little worse. Now again, if you're not using MyISOM, it probably doesn't matter, but you know, it doesn't cost anything to set this. Character set server equals UTF-8. By default, MySQL's character set is Latin 1. MySQL's collation is Swedish. Now what is collation? It's the way you order things. So, you know, A comes before B, or capital A comes before lowercase a, however that happens, that's your collation. Latin 1 Swedish because, you know, that's Monty. Monty Videnius, who wrote MySQL, the software that we use. So character set server equals UTF-8 will save you a lot of hassle in the long run, because if you're storing non-Latin 1 characters into a Latin 1 table, you can actually do that. But if you try to actually convert the table to UTF-8, then you get gibberish. Some more gotchas. Skip name resolve. So by default, MySQL does a five-way handshake when you authenticate. So you say, okay, here's this user at the host name, and here's my salted password, and I'm sending it to you, whatever, and I'm coming back. Well, one of the things MySQL does is if you're using host names like monitoring.mozilla.com, it will try to do a DNS resolution. So if your DNS is slow, then you'll see in your, when you do a show process list, you'll actually see these things called unauthenticated user, which might be really scary, but that means is it hasn't finished doing that handshake yet, so it's not authenticated. It's not gonna run any queries, but it's not authenticated yet. When DNS is slow, those can kind of start to pile up. You might run out of max connections, whatever. So a lot of people just do skip name resolve. If you do that, then your user definitions, your hosts can't be host names. They have to be IP addresses. And we say can't. MySQL is very user-friendly. What will happen is you'll get, when you start MySQL, you get a little error, a little warning in your error log that says, hey, by the way, I'm throwing out these host names. I don't know what these are because I won't be able to resolve them, so I'm not really using them. So when I say can't, well, that's not really true, but you shouldn't have it because you won't be able to authenticate. You'll figure that out pretty quickly. InnoDB file per table. By default, this is set to 0. It's not set at all. You want to set it to 1, or if you just put the phrase InnoDB file per table in your config file, it'll set it to 1 for you. What this does is it means for every InnoDB table, it has a separate file for data and indexes as opposed to the centralized data dictionary. The problem with that is that if you have the centralized data dictionary and you defragment a table, you know, here's your data dictionary, you're defragmenting the table that lives here. Well, now you've reclaimed this space here, but it can only be used for this table. The other difficult thing is it's hard to see how big each table is. If you're using InnoDB file per table, you can easily see how big each table is because you can ls the files and look at them. Temp table size versus max heap table size. MySQL writes to temporary tables, things like that. If there's a maximum size that it will write to a temporary table before it starts to write to disk, so if you have a lot of intermediate results, it'll write it to a temporary table in memory, but then it'll have to save it to a disk if it gets too big. Well, that size is determined by both these parameters, and it's the lower of both of them. So I think in one version by default, one was set to 16 megabytes and one was set to 32 megabytes, which is ridiculous, which means that your temporary table size can be 16 megabytes. I think they changed it to be either 16 for both, 32 for both, but just if you realize you want to change that setting for temporary table size, you have to change both those variables. So that's something that's kind of a gotcha. InnoDB parameters, you want to make sure that you set the InnoDB buffer pool size. Some people say 80% of your total memory if you're using InnoDB as your main storage engine. If you're starting to get like 64 gigs of RAM, that might be a lot in one go. So yeah, it's something to think about, like what's your active working set? How big do you want your buffer pool to be? InnoDB flush method, so you can actually, in some like versions of Solaris or whatever, you can actually use different flush methods to flush your logs to disk, and it can be faster or slower. Again, some people say, well, if you're using Solaris, do this. If you're using Linux, do that. Test, benchmark, have fun. InnoDB flush logs at transaction commit. By default, when you commit a transaction, and if you're not using transactions, just when you enter in a statement, MySQL flushes the logs to the disk and waits for it to flush to the disk. It flushes the log to memory, and the memory logs flush to the disk. If you set, and that's the default, which is 1. If you set it to 0, it just doesn't worry about committing it to the log or the disk. If you set it to 2, InnoDB flush logs at transaction commit equals to 2, what it will do is it'll flush it to the memory, but it won't bother to wait to flush it to the disks. So you might have like a second of transactions that are lost if you do that, but you don't have to wait for that I/O to happen. So on large systems where it's okay to lose like half a second of data or a second of data, usually you set that to 2. Logging. So there's a lot of logging. In MySQL, you want to make sure that you're error logging. It doesn't error log by default. You want to turn it on, make sure you specify the file, and do that. Because sometimes the default place it logs to is a little obscure. So I think it does actually log to varlib MySQL hostname.err. But sometimes it doesn't log. I'm not quite sure exactly when it does and when it doesn't. I would always put log warnings because the warnings are usually not noise in MySQL. Expire logs days. Yep, this is in MySQL when you have binary logs, they can just keep filling the database. After expire logs days, every time MySQL flushes the binary log, it will look to see how old the oldest binary log is, and it will actually purge up to that number of days. So if you're doing like daily backups, you can probably set expire logs days to 7, because when are you going to have to go to the last 7 days? But if you're like taking a backup of something over a weekend or something like that, you might want like 3 or 4 days of logs at least. More logging, log slave updates. So I was telling you about replication and how replication from the slave goes to the master, takes the binary log, saves to the relay logs. Well, by default, MySQL does not log in its own binary log on the slave any transactions that come through the master. It only logs what happens on the server. What happens on the server stays on the server, right? But so usually what you would want is log slave updates, because if you have to play detective, you want to know what happened on that server. You don't just want to know what initiated on that server, you want to know everything that happened. So you want to hit log slave updates. Similarly, if you have the slow query log on, if there are slow queries that are coming from the master to the slave, they're not logged by default. You want log slow slave statements. Similarly, if you want administrative statements like optimize table to be logged, you want to make sure that this log slow admin statements is set. Long query time, so by default, the slow query log's not on, you're going to want to turn it on, and I think I have a slide later with some of those parameters. I may not, but anyway, it's like slow query log equals on, and log output equals file, and slow query log file equals path to file. So long query time by default is 10, which means that anything over 10 seconds, you'll see. That's really long. Your users are way gone if your website takes more than 10 seconds to load. So some people set this to 0 to show everything. Some people set it to 2. I only want to see things at 2 seconds, but you probably don't want the default of 10. Log queries not using indexes. Can anyone guess what that does? It logs queries that don't use indexes. Right, which is great, except when you have when you have a table of like 10 rows, that's probably never going to use an index. Like if it's like 10 rows and 2 columns, you probably don't even have an index to use. So there's another parameter called min examined row limit, which makes the minimum examined row limit of files that show up in the query something. So you might want to say, show me the queries not using indexes, but only if they're like 1,000 rows or more. Because if they're less than 1,000 rows and not using an index, I don't care. Max connections we already talked about. Max connect errors. So here's something interesting. By default, max connect errors in MySQL is 10. What that means is there are 10 tries that you get to log in with a correct username and password before you're locked out. So if you log in 3 times with the wrong password and then 1 time with the right password, the counter's reset. By default, it's 10. You log in 10 times in a row with the wrong password, and your account is locked. That's pretty cool, right? And you probably didn't know about it, so 10 is probably a pretty good default because you didn't even know about it, right? Well, what happens if you want, so first of all, this is a global parameter, which means that you could say Sheeri is allowed to have 10 errors before she connects, but John, he can only connect 3 times before we lock his account. Nope, you can't do that. There's only one global setting for that. The other thing is when you unlock, how do you unlock the users? You do a flush hosts, or when you restart MySQL, things go away. So you can't unlock Sheeri but not unlock John. So it's a pretty cool feature to have, but it's kind of sucky that it's global. Max allowed packet basically is the maximum allowed packet that MySQL allows to read or write. When this is a problem, it will be really obvious. It will say, Can't do this because max allowed packet isn't big enough. Increase the size of max allowed packet. That's the error message. So you don't have to worry too much about it, but you probably will see it in your travels. MySQL Query Cache. I have a Query Cache assistant here, which is actually really very useful. Let me go to the tab group that has it. Slides. Here's this query cache tuning. So by default, MySQL has a really crappy query cache. I would go into exactly how it works and you can see how crappy it is. But this is a very simple query cache tuner. You don't even need to write it down because the optimal size for your query cache is 0. Don't use MySQL's query cache. You can use it if you have a specific implementation of it, but I'm going to run out of time, so I'm not going to explain how it works. There may be a use case for it, but 99.999% of the time you don't need it. There are some other caches that you're going to want to set. I think I'm running out of time. There's some timeouts. The difference between wait timeout and interactive timeout is that wait timeout is the timeout for when you have a non-interactive session. So like if PHP is connecting or whatever. If you actually log into MySQL, you have a command prompt and you're sitting and waiting, that's an interactive timeout. So you can see how you might want to set those values differently. Oh, and now we're at the end. Are there any questions or comments? I wrote a book called the MySQL Administrator's Bible. You might be interested in it. It's a couple years old at this point, but most of the information is still pretty valid. You can ignore anything about Falcon in there, because that's no longer a viable storage engine. And there's a lot more new in the Percona and MariaDB patches and forks. Any questions? Comments? Feedback? Anything you want to know about? Let me explain to you what the query cache does then, very quickly. So the query cache stores a couple of things. It stores the hash of the query. So it takes the query and makes a hash of it and stores that. And then it gets the results and it stores those. And then it also has like the list of tables that are affected. So it stores those, and then if you run the same query again, it will say, oh, it checks this little hash table. It says, oh, I've seen that query hash before, so let me give you the results. That sounds great. The problem is, if you change a value, so it's not going to actually compile a query and do it that way. So if you have like select star from user where user ID equals 1, that's a different query from where user ID equals 2. So it can't use the cache in that scenario. If you change capitalization or you change white space, it's not the same query because it's the hash of the query itself. So it's not very useful in that situation. The other thing is, I said it stores results. It also stores a list of tables that are in that query. If you change the data in any of the tables that a query uses, MySQL invalidates it because it has no, it's a very kind of dumb kind of query cache. It has no idea knowing whether or not you actually changed any of the rows in that result set. Maybe you added rows that would show up in that result set. It doesn't know. So you might think, well, we'll take our sessions table, we'll put a query cache on it so that is all cached. But your sessions table is being written to all the time. So it's just going to be put in the cache and invalidated, put in the cache and invalidated. So there are use cases for it. There's 3 different kinds of query cache types, 0, 1, and 2. So 0 is off, 1 is on, which means every query by default will be tried to be put in the query cache. And then the third type is 2, which is on demand. And the only reason that I would ever recommend somebody using it is if you specifically have, there's a query that's run all the time and that table doesn't change a lot. So it falls exactly into the use case for query cache, then you can actually do an on-demand kind of thing. You set the query cache type to on demand, which is 2, and then when you run your select statement that for the one query that it's good for, you type, instead of select star, for example, it would be select SQL underscore cache star. So you put that little keyword that says cache this query, use the query cache for it. Okay, that's how the query cache works. Any questions, comments, feedback? Do I need to wake anyone up? All right, thank you so much.
When we created Asterisk over a decade ago, we could not have imagined that Asterisk would not only become the most widely adopted open source communication software on the planet, but that it would impact the entire industry in the way that it has. Today, Asterisk has found its way into more than 170 countries and virtually every Fortune 1000 company.
The success of Asterisk has enabled a transition of power from the hands of the traditional proprietary phone vendors into the hands of the users and administrators of phone systems. Using this power, our customers have created all sorts of business-changing applications, from small office phone systems to mission-critical call centers to international carrier networks. In fact, there's even an entire country whose communications infrastructure runs on Asterisk.
Digium has always been about creating technology that expands communications capabilities in ways that we could never have imagined. And that's part of what's game-changing about Digium. Today, we're doing it again, this time by introducing a new family of HDIP phones that extends control of the user all the way to the desktop.
The launch of these new products represents the next phase in Digium's history of innovation. These are the first and only IP phones designed to fully leverage the power of Asterisk. When we first discussed our expectations for building a family of phones for use with Asterisk, our requirements were pretty simple. We asked the team to build the phones such that they were easy to install, integrate, provision, and use. I think you'll soon agree our engineers have delivered on that goal. User feedback is validating that when it comes to operation with Asterisk-based systems, including our own SwitchVox-based product, these are the easiest to use, best integrated, most interoperable products on the market today. The Digium family of phones will initially include 3 IP desk phones, uniquely designed to complement any Asterisk or SwitchVox-based solution. These phones are different for a number of reasons. First, they're exclusively designed for use with Asterisk. Secondly, we've made it really easy to auto-discover and provision the phones. Next, we've made it easy for the phones to access information inside of Asterisk, allowing tight coupling between an application and the phone. Additionally, we've created an applications engine that allows users and developers to create and run their own apps on the phone. And finally, we've done all of this at a very compelling price point. At Digium, we're always thinking of ways to give our customers the best value in business phone systems and also give them the power to create their own solutions for any communications challenge.
We'll continue to push the boundaries, not only to make Asterisk cooler, faster, and more technologically feature-rich, but to make Asterisk and VoIP communications even easier.
And together, we'll change the way the world communicates.
Again.
Cloud stacks are everywhere.
This is the way to better utilize all your resources, and it makes managing all your resources pretty easy.
All of the innovation is happening in open source.
The collaborative nature and of the community and the speed at which these deficiencies, these bugs are getting discovered and fixed is a thing that really shows the power of the open source community.
It is global, and it's definitely because of the users.
Community people are extremely friendly and always ready to help.
If you go onto IRC any day, you'll see these guys helping each other out, and they're all doing it like in a selfless manner.
The product is transparent for everyone. Everyone can look at the code base. Everyone can see how CloudStack is being built. Nothing is proprietary. Everything is open.
In many ways, it's absolutely vital to the ongoing health of CloudStack.
The most exciting event in recent memory for me was our first developer boot camp. And our call gave people, I think, maybe 2 weeks notice to come attend. I was expecting 25 or 30 people. So we ended up with 87 people and had to go get more chairs into the room twice.
Everything within cloud computing is commodity and is open source. And so I don't think that you will you'll see anywhere where open source is not pervasive in cloud computing. And so I think it's an assumption. I think when you talk about cloud computing, you're really talking about open source cloud computing.
CloudStack is a robust solution for large deployments.
You have dozens of data centers and thousands of servers in each data center. These hardware is going to fail, and CloudStack is designed to handle, number one, that mass scale, number two, It's designed to handle the failure that inevitably happens in large deployments.
We started working on CloudStack over 4 years ago, and it was the original set of people working on it had a background of delivering software to telcos and service providers.
Lots of QA, lots of users actually using it.
High availability is the key feature. Multiple hypervisor support, different network models. You can pick up whatever suits you better.
CloudStack management server can be deployed in different physical machines.
It definitely has a huge footprint. It's being deployed everywhere.
There's a major movie studio that they were using CloudStack. They were using it to transcode video, and I thought that was terribly fascinating. What I found more fascinating is what they did during lunch, where they would spin up 50 or 60 game servers. Then as soon as lunch was over, they would destroy all the instances and go back to doing real work.
CloudStack is vast. It touches so many different aspects, and there's no one person that's kind of like a master of all those realms.
I think CloudStack as a project is going to be one of the leaders, simply because it's some of the most featureful and robust platforms out there.
I don't see any limits to the CloudStack.